Welcome to another Steel and Whiskey episode. I'm David Zabka. Got a pretty special guest with me here
It's
today.
special.
Yeah, special.
I'm Doug Evans.
A lot of you guys know Doug, so we've got, of course, we've got our whiskey. Always drinking our whiskey. So I got a great story for this whiskey.
It's not a great.
It's a pretty good story. So Doug and I had a little bet. It was a football bet, right?
Yeah. We live in Nebraska.
Live in Nebraska, so of course we're big Cornhusker fans, all that. So beginning of last season, Doug, well, it was before the season started last year. Doug came to me and he said, "Well, what's the over unders on wins for the season?" This was still in the Scott Frost era, so last year the Scott Frost era. I think the over unders ended at 7, right?
7, I think 7 wins.
I took the unders. Good choice on my part.
I'm in sales on the internal optics. Nothing said that we were going to do it. I thought we could do it.
Yeah, well, I think we ended up with 3 wins. 4, yeah, maybe 4 if we were lucky, but 2 of those came from the interim head coach. So,
Wasn't close.
So the bet was whoever won would receive a bottle of whiskey that had to be at least $150 in value. So, I'm going to thank Doug for this whiskey.
The truth be told, I just wanted to buy a bottle of whiskey.
And I just opened it, first time opening. So, I get the spoils, but I'm also nice enough to go ahead and share.
I'm going to share for it. I might as well have a little bit of it.
Yeah, exactly.
Whistle pig.
Whistle pig.
You're right.
Yep. So here goes first taste. See how it is. Pretty good. It's pretty good stuff. So yeah, well, worth the money, I would say.
Yeah,
Well,
sure.
yeah, little sweet. That rides a little sweet sometimes. So yeah, very good.
It's pretty smooth. There's not a lot of bite there.
Yeah, no, not at all. So you know what, Doug and I talk all the time. We could sit here and talk forever. I know Doug's always constantly talking to detailers. I'm talking to detailers all the time. And, over the course of the last several years, I would say it's really been a topic since I started working here 16, 17 years ago. I'm sure you've heard it more than I have, but it seems to really progressively have gotten worse. Design drawings and the condition of them and missing information, things like that. So that got Doug and I talking not that long ago about, well, what is a steel detailer? Who is a steel detailer? What is a steel detailer? Why do they need this information? Where'd they come from? Why is it all of a sudden so just a range of topics and things?
And we talk, like we said, and this is completely unrehearsed, so it'll be free flow information. But oftentimes here, I've been here a lot of years, I ask, what do we really sell? And that's kind of where I think the last conversation was. It's like, what are we really selling? What is the value people are getting from it? It's changed. I've been here over 20, 30 years. It's changed. The value's changed on what people are buying and versus what we're selling, kind of thing. The product's been the same, but the value they got out of it is the same. And that's a lot because the function of a detailer has changed over the years. And construction technology in a lot of places is changed. And so if you go back to know where to go, you got to know where you are and where you've been. And so we were talking about that a little bit, to take it from knowledge of knowing what happened to try to create some wisdom with it. And I remember when I first entered the industry, or did you have a point?
No, I was going to ask where we then give us a history lesson to begin with, right? You've been doing this longer than I have. I'm not gonna share numbers or age. I don't want to embarrass you, but
I had hair when I started.
Well, I did too, and mine's all gone. So where were things when you started?
Yeah. So that's my experience where I started. So it's computer aided design in the industry, right? I won't get into the hardware, software isms of it, but really a real popular method was takeoffs, kind of what you would see in estimating now, where you look at it, and you take it off. And so they put it on these sheets. And then when you talk to computers ahead of, we'll say we're post dating, just manually drafting in AutoCAD or by hand in pencils and T-scores, which I saw at the time. But you would put this stuff on a sheet of information, the size of beam, size of column, and it would regurgitate out a simple 2D drawing, or maybe it would just give you the beam and you would do some graphic stuff on the end.
So let me back up a little. Let me make sure I understand that. So at the time, it was almost like you were entering information in a spreadsheet, and then you would get a 2D drawing of some sort.
It would generate a CAD image of, depending on how the different systems, it may have just given you a beam with 2 clip angles that you had to add dimensions to. It may have given you some dimensioning, but it was just generating the 2D.
So just the wire outline and maybe not even necessarily dimensions or anything.
And to be fair, at the time, SDS2, I'd shown up in what we called the framing plan approach. So if you did look at how we built buildings, or the documents needed to build a building is architects would do their thing and engineers would do their things. But in the end of the day, you would get this plan. You'd get the plan and elevations of what we're going to build. And so Jim Dager, the founder, had gone to a framing plan approach, where you would just copy the plans and elevations of information. And then we had that little bit of automation and just plan elevation of connections to create the 2D drawing set. Where other companies would just take the plans and elevations and then just put them in spreadsheets to create the 2D drawing set.
Okay.
A certain percent of it was done as far as connection information, but a lot of it was just get as much as you can into the 2D world and just line, arc, circle from there.
So was AutoCAD around at that
For
time?
sure.
How were people using? I imagine it still is a mix today, but I imagine it was a mix of that kind of spreadsheet entering, spit it out. Imagine there was probably a certain amount that were just using straight AutoCAD.
Most, if not all, the systems that existed back then are gone, except for just the drafters, like the 2D AutoCAD stuff. But then this evolves into why we wanted to have the discussion is the spreadsheet implementation was really fast. Like if your only intent was to create as much 2D as you could, it was a really, you could argue that it was a very efficient way to do the role of a steel detailer at the time. It was efficient, clean and efficient.
So this goes back to something I always talk about. Good, great whiskey. So this goes back to something I always talk about around here internally at SDS2 is, well, that's great. What's the delivery? What is a customer of SDS2 that's going to buy SDS2? What do they have to deliver to their clients? Because that's really the value of software, is that end result that the person buying it and is going to be using it. What are they getting out of it that they can deliver to their clients? So way back when, so we're still history. We're still the beginning.
Park the conversation. Let's go back.
Yeah. So we're still at the beginning. At that time, when you started doing this, what was the deliverable that a steel detailer would provide? What was their product?
Well, and that gets to, like I said, we evolved the conversation here, and now we're going to rewind. So let's just look at the broader. How do I build a building? When I entered, what was the progress of information flow from this person to this person, and what are the different roles within each organization that allowed me to, at the end of the day, get a structural steel building up in the air that we could house. And so, and we'll just take from the engineering to manufacturing, right? Just kind of stay there. And there's different offshoots in industrial and commercial for sure, that have a little different need and workflows and roles. But the engineer would figure out the size of the members, right? And where they were placed in the field. Like, this is going to go here. It's this size. and would make sure that it was a structurally sound, safe building. They would make sure that that was good. They would have some specifications on connections. When I first started, it was a lot more concise. It had a lot more robust information on what they would like you to do to build it. But really, it's like, here's the building, and the manufacturer had an ability to connect the building, to create the welding and the bolting in a lot of cases, again, depending on regions of countries. And there's a lot of isms here, but the fabricator would get this building that they would have to figure out how to build. So this is structurally sound building. Floors won't fall, it won't blow over in wind, snow loads are fine. This is a structurally sound building. Now put it together so that we can have it fabricated.
Yeah.
And I give you some general ideas on how to do that as an engineer, but a lot of times it wasn't completely laid out. So the detailer then had to interpret the plans and elevations and create another set of drawings for his shop floor to say, these are the holes, these are the welds, these are the materials that I need for you to punch, cut, links, all that stuff they had to figure out so that we can fabricate it so it can work in the field.
So the deliverable at that time was, for a detailer, was a 2D shop drawing.
And a bill of material.
And a bill of
Which was
material.
very critical at the time. People that were in AutoCAD had no bill of material integration, where we could really provide that bill of material, number of bolts.
So they were filling their bill of material out.
A lot of times
That's what they were doing. Or if you were to go back even before that, hand drawings, the deliverable, again, it was a shop drawing, bill of material.
Right.
All hand drawn.
All hand drawn. And
Right.
there was an art to it. Like detailers were part artists. Their artistry on their hand.
Yeah.
Very important to them, which is why fonts were important to us, the older detailers.
Don't get me started.
So that was the progression, right? So that the detailer's role in 1995 is staggeringly different than what you're asking them to do today.
Because then, so if we look at the progression, absolutely, I agree. So look at the progression then. So you go from, the framing.
They called it the framing plan approach, and we didn't even do skew. It was all just perpendicular parallel. There was no skewed beam to columns. That was a feature back in 1998.
I would imagine back then, there was a lot less skewed.
Yeah,
Need for
sure.
skewed, right? Because it was more difficult with the tools back then, so they probably didn't. Nowadays, it's easy with modern software, modern technology. It's easy to skew stuff.
And
Most stuff.
And everything, and Eldon Strassheim was one of the engineers here at the time. Would always say, if you broke everything down to its least component, it was pretty easy. But so like a skewed, then one set of math equations was easy, but the group of math equations to make it all work was fairly difficult.
Right.
So,
yeah. So we go from, framing plan approach, deliverable that you got to get out is shop drawings and bill of material.
Right.
So then, probably reporting and such stuff like that, right? So, but then what would have been the next leap where a fabricator or someone else was saying, okay, Mr. Detailer, I've got this thing, provide me information so that I can use it.
Well, there were two, I would say, that were very close to themselves. CNC machines, right?
Yeah.
When the advent of a lot of those mag drills, if you look at drafting standards, I would go to shops, and drafting standards, detailing standards for the shop were very important, because you were manually laying out your chalking things and you're using tape measures, and it was real important that shop had a standard that they wanted you to follow. Not even considering connections, but just a dimensioning style. And then there was some checking dimensions they wanted. So there was a lot of dimensioning style discussions back at that time. So that was important. So CNC, all of a sudden I could take digital information and reuse it instead of recreate it. So there was like this huge savings and this huge concept in the industry. And then at that same time, you had digital information that could be reused in ordering steel, which was a very big savings. I didn't have to re-enter all the information. All of a sudden I had this database that I could pull from and use in different parts, which that small concept then has just exploded, and it's workflow related, right?
Mhm.
It's not just within an office.
And it's one of the biggest parts of BIM. It's the middle letter,
It is big.
information. Everybody wants more all the time.
And the ability to reuse it
Yeah.
instead of recreate it.
Right. Yeah.
I can't tell you the number of people both on shop floors that were just recreating drawing information,
Mhm.
people in back offices that were recreating information that existed somewhere else.
Mhm.
Someone input it somewhere, but it had to be recreated at every phase.
So there's a lot of duplicate work that is now,
Consistency goes up.
now it starts
Quality
to be,
goes up.
okay, we've got this information, we've got this data, let's use it across everybody that needs it versus recreating it over and over and over
Right.
again. Right. Okay. And so the two things there then, it's CNC information to run at that time, I imagine what were probably pretty basic single spindle
Three
drill
spindles,
lines.
single spills,
And then
single,
that-
and then an angle,
Sure, angle line.
lines.
Yep.
So there were some pretty simple machinery.
Gears, punches, they evolved into probably like a 3 spindle
Then a 9
type
spindle.
of drill, then a 9 spindle for 3 different sides, and yeah, so, and then also probably like KISS files, but right, you talked about for ordering purposes and
For sure.
and such, so it would have been things like that to send to the fabricators. So okay, so you go from the deliverable is shop drawings and a bill of material. So that was a detailing. And then you evolve into shop drawings, a bill of material, CNC information. We'll use the old term EDI, electronic data interchange, right?
Well, that really started showing up. That term showed up more when we started passing design models.
Sure.
That was kind of another phase of this.
So-
Hey, is some engineer did this already? Can we use it?
Yeah.
EDI.
So we're kind of looking at, so we're phase 1, shop drawings, bill of material, phase 2, CNC, and I don't know, whatever we want to call it, EDI or basic ordering. Now we're on a third phase, kind of a third deal here, where now we're looking at actually exchanging models then, correct?
Yeah. So if you look at the difference, and there's a whole various discussions I want to get into around what you've just said, but the first two, the two that you just mentioned, are me reusing data internally,
Mhm.
right? So within the workflow of the project,
Mhm.
once it gets into my office, I'm going to build it in this model, and then I'm going to use it for my shop floor, and I'm going to use it to order.
Yeah.
The third thing you said is actually some other company
Yeah.
is in this workflow has done some work in a digital world, and I want to reuse that to shorten my time frame.
So this is interesting. So you're talking about a fabricator hiring whether it's a detailer that works for them or a subcontract detailer. So that person I'm hiring as the fabricator provides me a set of information. Now we're talking about a detailer, a fabricator hiring a detailer, but now that detailer has to not only provide information for me as the fabricator, they have to provide information to another party.
Yes.
Right?
And
That's essentially what it boils down to.
and I mean, fast forward. What it might ask is a hire of a detailer. Give me a shop drawing and some bill of materials for the shop floor. Be able to interpret plans and elevations so you can figure out how to get there.
Yeah.
And then they had to have this innate ability to see 3D so they could kind of make sure everything fit. So that was kind of the requirement of a detailer then. Just pretty clean, pretty clear. I understood it. Exponentially changed today. In addition to, and part of the discussion we wanted to get into, maybe I'm bringing it in too early, is that there has been it'll be an infinite shift between having these people that do this inside a manufacturing office or external. So the subcontract detailing office was a newer thing in the 70s and 80s, let's say. It was always within the fabricating office. Then now you had these subcontract detailers that could do it for multiple fabricators.
Yeah.
But it was a pretty clean ask. It was like, hey, I need you to do shop drawings and a bill of material for my shop. And so I've seen this pendulum go back and forth over the years. The last cycle is fabricators have been kind of pushing it out more towards subcontract detailers. I'm starting to see, because of the ask, if I just want, as a fabricator, if I just want shop drawings and maybe some pretty simple CNC files, it's understandable in today's world. But if I'm asking it to do robotic welding and wait, if I'm asking, I'm no, but I'm just going to kind of present the problem. If I'm asking,
not even to that progression yet. No, we're only on progression like what, 3 or
12,
4 yet. You're on progression 12.
But the reason why it swings is because as a manufacturer, I've felt something's important.
Yes.
And so at one point it was just drawing production, and I didn't want to hire so many people. Like the bottleneck was I didn't have enough drawings to keep my shop busy. I need to outsource it. So then the pendulum swings and I outsource. Now I have enough drawings. I got more people out there. And then it's like, okay, maybe my quality or my information that I'm getting to the shop isn't clear enough. I need to bring that in and control it. And we swing back out. Okay, we've got some base level standards in the industry. We can do CNC better. I can get it out. And now I'm asking it to route my shop, and I'm asking it to
step 13.
Yeah, that's step 13, but we're asking it to do. So now you're starting to see a shift again. And there's kind of another division on that shift I'm seeing.
So what, throughout all of this,
Yes.
then, so we're talking about how the steel detailer's role has evolved, what information it is that they provide, what their end deliverable is. So who has anybody like stepped in to say, hey, we should help the detailer out. We should be doing our part, or has it always just kind of been, give me this, Mr. Detailer, and if you don't, I'm going to go somewhere else and find somebody else who will give it to me.
Well, and
What's your experience?
my experience is, so detailers used to kind of, that was an entry job for a lot of fabricators. And as they improved and became knowledgeable, they got to go to project management and estimating.
Okay.
So that's was the olden day. Now what a detailer is can impact a project, and people are recognizing it. I don't know that there's a, NISD, there's not anybody kind of looking out for them within the workflow, I would say. But certainly we've all heard that the 80% of your quality is determined in 20% of the first 20% of the project. And I think a detailer has so much impact on that. And the ones in the manufacturers that have seen quality detailing and control of that reaps the reward of that, sure. So I think they understand, they whether they see it or protect it, you feel it in the pocketbook or in the in the problems later on in the project.
Yeah. So then it's fun. And so we've gone from shop drawings, bill of material, CNC, call it ordering additional bill information, to model interchange. And now we're
subcontract
coordination. And then I remember we'd probably get to about the point just shortly after I came out of college, honestly, and I was in our support department here. Some of the big things were like, get me a model to Navisworks for clash detection. I remember that, just old Vermal files. They were just
VRML.
Yeah, VRML. And it was, man, the big thing was Navisworks was just this ever-changing thing. But then it became one more thing that, okay, well, the detailer has the fabrication model, so we have to get it from them because nobody else has that information.
Yeah, the good and the bad of SDS2 or steel or I wouldn't even say just manufacturing models. The good and the bad is we are what gets built.
Yeah.
So you can architecturally say, I want something that looks like this, and create a model for that. And you can engineering wise say, this is what will stand up in the field, but they're not accurate to a 16th of an inch. Whereas
like the detailing,
has to be built. And so when that happened, that became the epicenter where everybody wanted to talk around. Because now I have coordination models with other disciplines, whether it be site work, whether it be anything you might see in industrial world. You got piping, you got P&ID, you've got all these other disciplines that need to be in harmony. I say work around, be in harmony with my structural building, and that's the one that's right.
Yeah.
And so having discussions around coordination on any other model is a guess. And so that's where the manufacturing became important. Hence, the detailer that controlled those models got themselves into a lot of discussions that they'd never been in. Drawing bill of material. That was it. That's not the case now.
Yeah.
Now they're flying people to LA and Seattle to have pre-construction meetings on half designed projects that are detailers because they need information from them on how to spaghetti piping or how to do the elevator shaft or whatever. So they became very important in the project after that.
And so technology has absolutely contributed to the complexity of projects, right? So going back to when you said your framing plan approach, you said we didn't do skew. It was all square stuff, right? Well, technology progresses and progresses and progresses, and then it's now, oh, well, it's easy to do skewed, so I'm going to do all sorts of skewed framing or sloped or curved or rolled. Like they just really absolutely start to push the limits. And you and I have seen a number of pictures where we go, why in the world would you build that building? Like you are tempting fate. You are messing with physics. And somebody's gonna get hurt one of these days because you're building.
I know your software said it was okay. I ain't walking into
building buildings leaning out way farther, and yeah, it's just nuts. So all the while that detailers are having to provide more information than they ever had to, the building complexity is more complex than it's ever been. So yes, we have all this technology. Doesn't mean that it's just a simple push of a button for a detailer because they've still got to figure out how it's built. How are we going to build this in the shop? How's it going to hold up? How are we going to erect it? Can we erect it? All those things. So it's
and I'm going to introduce the 18th and 20th problem or discussion.
I think that's about where we're at. Yeah.
Is that with construction technology and model building. So today, any reasonably sized structure has a model behind itself. And what I can do with a number of models, there's a lot of tools that do a lot of things. As an architect, as an engineer, as a manufacturer, as a field guy, they may all build separate models, but how far I take the level of development, whether you want to call it LOD, whether there's a number of terms you can take it. But let's say as an engineer, I design this and I've got correct section sizes. I predict a material of steel. I've got section sizes and my coordinates are fine. How far of a leap is it to go to the next step? Like, well, maybe like we have customers that, hey, let's just generate the connection so there's no ambiguity. We'll just build a model and pass the model with connections. We've got people that'll go all the way down as engineers, and then we've got people that'll just pass maybe a RISA model to us. So there's where's the line? You know, as a non-educated layman that sees a 3D model, it's like, oh yeah, it's a 3D model. But how far do you take the level of development and whose responsibility and who gets paid and all this discussion that happens is an interesting conundrum that we have. I mean, it's certainly interesting, and that ability of the products is changing responsibility of what is a detailer, what is an engineer, what is whose job is this function. And it used to be pretty clear. Here's a set of drawings, go from there.
Build material.
Here's a set of drawings. Now, how far I can develop in the effort, the risk reward, right? The risk of developing this information and the reward I get back as far as revenue and project shortened cycles and that kind of stuff. Is just the constantly switching battle. And with each organization, someone loved the risk for the additional revenue, someone will hate the risk for the time, so.
Yeah. And to be clear about all this, we're just kind of sympathizing with all the detailers out there. So,
Because
I love technology. I think technology is great. Technology is amazing. I wouldn't enjoy the job that I have if I didn't, believe in technology and all those things. But I certainly understand when I talk to all the detailers and all the gripes and that of more information they have to provide, all that good stuff. Like yeah, totally understand.
and they're not even, I mean, again, and then to the evolution of a detail, I don't even think they're detailers anymore. Like
There's so much more.
For the definition of bill of material shop drawings, they're project managers, they coordinate the job sites, they do so much more.
Detailing is one small portion of what they do.
Yeah. It's not just production of beams per day, which was a category you would purchase detailing systems. How many beams a day? How many beams a day? Now it's this overall information of how I can translate it there and what I need to do and how do I run your shop, and gets us to the next pendulum, right? We're talking about that a little bit.
Well, so let me back up. Let me ask you a question about you and your role. So how has all of this changed the way that you do your job? I mean, it had to be a lot different back then when you might have been, I don't want to say the only game in town, because there was others, but you were one of few, and technology was
There's a comedic,
so different then.
I'll give you they do comedy, you do a recall. So I go back, it was sheets per day in production. So that, what are we selling? I would ask myself that annually, every other year. What are we really selling? And at the beginning, it was sheets per day. It was how many sheets per day, how much production could I get out of the system to get sheets on my shop floor? And so that was knowing that's what they were buying. What are you buying? They're buying productivity of their individual steel details. That's what people wanted. They wanted productivity of their drafting department so they can get more sheets on the shop floor. You keep asking yourself that question, and it's not sheets per day anymore.
That's almost an afterthought anymore.
Yeah. It's more information. Can I run? Do I have this data field filled out so I can suck it over here into this field? Do I have this file so I can make that work?
Can I get a labor code?
Can you import from here?
Does it work this machine, this file?
It's like, hey, I got 30 sheets done today. Don't give a damn. Do you have these things?
Yeah. Can you route it through my shop or whatever it is?
And we've been in the last cycle of macroeconomics. We've been in pretty good. Most fabricators are busy, and so it's nice. Now they need higher production from their machines or their routing or their material handling, and they need somebody else to give them some data field so they can route it, handle it, punch it, cut it, weld it quicker than they could before.
Yeah.
So that evolution's had, and when you ask that, you're asking different things from a detailer, and so that pendulum again's coming back, and to where I need more control over that, because I don't need the sheets per day. I don't need 100 people detailing this, but I need the right information for this. And so that's what makes me money as a fabricator. And then if you look at the workflow, architect, engineer, fabricator field, who's doing the detailing, I think is going to start to separate, because it's becoming important to the project that I get things done in the field. We saw a huge Amazon, Facebook, like all these warehouses have just sucked a lot of it in the last couple of years. While that has been dying down, the need to get things from concept to field is very important. And again, whose responsibilities what is, it's a moving target.
Yeah.
You're starting to see owners or engineers taking more responsibility and taking that model development way further. So as that pendulum swings, is it going to swing to external, internal, or maybe engineering firms? We certainly have many engineering firms presenting shop.
Yeah, for sure. And it seems to make a lot more sense, right? Because you're having, as a detailer, you have to constantly communicate with these guys. So why are we not just part of the uh, same corporation? Why are we not part of the same company, the same team? I mean,
It begs the
should,
question.
should be working hand in hand because, and I honestly, I don't think that one is more important than the other, right? So it's a team concept.
Yeah.
The team, it has a goal. That's to build a building, right? And if one person doesn't do their job correctly, then the whole team fails and the building doesn't get done the way it should. So it's engineer plays a role, detailer plays a role, GC, everybody plays their role. I always think about it like football team, right? It's
I've heard this a number of times in a number of ways, but I'll cobble that into one statement is the best project I was ever on, right? An engineer might say or just say, remember that one project that went great. It never had anything to do with, oh, that went great because I used X product.
Yep.
It was, that went great because we had outstanding communication on our team of people that were building a building.
yes.
And that communication may look like integrating files,
Mhm.
EDI, reusing data, whatever, but it was outstanding communication that led to the technology to perform at its highest level. And so it's that team approach for sure.
I absolutely agree with that. I'm always all about communication. I preach communication to a lot of different people in a lot of different ways. In fact, I was just on an NISD webinar last week talking about interchange of information.
This is good.
Do you need a little bit?
No, I'm good.
Are you sure?
Yeah.
You're just getting too old. You can't handle it.
Uh,
Okay. But yeah, so I ended the whole presentation with communication. Guys, if you don't communicate with the fabricator and the guy running the computer over here that you're passing information to, how do you ever know that the information isn't what he wants or what is expected?
Technology
or if
doesn't
there needs to
solve
be an
that.
adjustment somewhere.
And
Always have to communicate.
if you compare it to automobile and mufflers and other industries, sneakers, like there's manufacturing in a lot of things. The glass was manufactured, the whiskey bottles manufactured. How do I communicate that to a manufacturing firm? It's steel has been different, right?
Sure, yeah.
And so
Well, the construction industry in general.
it's construction, yeah,
Yeah.
yeah, for sure. And so how much of the design firm can take to explain to the manufacturing firm, this is what I want.
Mhm.
How far you develop that model.
Yeah.
And we've seen the gambit.
Because it's all, I mean, it's all the trades are very, very much separated, right? Typically you've got GC and they're subbing out to all the different specialty trades and then there always becomes a disconnect and it's just, unfortunately, a lot of the industry has just accepted that, well, that's the way it is, but
Yeah.
I don't think it doesn't have to be that way. You know, some have figured it out, some have gotten better and gotten more tight and communicated better. So there certainly are those out there who are doing it better and have changed and done it differently. I would say majority is still doing it the old disconnected way though, aren't they?
And then it goes back to the communication, and it's not going to go more siloed, right?
Okay.
We're evolving, so you have to learn to play in the world, and you're going to have to learn to be more transparent and sharing your models and that kind of stuff. And number 19, which we haven't got to, is cloud, right? So you're going to have to
Yeah.
now if I have a cloud model,
Mhm.
and if you could envision the day where a single model was you just watch it build from architect to design to manufacturing to field, and it was the same thing that just kept growing and growing and growing, all accessible by everybody. That I may have as an owner of a manufacturing firm, 7 guys doing stuff to that model. You may, as a design firm, have 4 guys doing stuff to that.
Mhm.
It may be just different people working on a
Yeah.
singular thing. So the concept, it's going to evolve, and who spends time where and who gets credit for or paid for is really the credit is
So
going to continue. Technology is not causing that, but it's if the communication's there and if the team is there. Yeah. I think that's the fantasy of how we're going to go forward.
So part of what I'm hearing you say is the role of a steel detailer probably isn't done evolving and isn't done changing.
Yeah, then, and to be fair, the role of a teacher, the role of a detailer, the role of a sales guy, like if you think you took a job in 25 and that's what it's going to be, that's probably short-sighted. But a steel detailer
It's got to change.
has certainly got to evolve with the times. And like I said, the ask is way better than way larger, not better than it used to be, but that's okay. Like change is fine, adapt and encourage it and try to keep ahead of it. And there's more coming.
Yeah.
Like we know that, right?
So I think you nailed it also. So yes, it is evolving. It's not done evolving. It's never done.
It's never,
But neither is an engineer's job, an architect's job, a fabricator's job, you name it. Everybody's job is evolving,
right?
All the time, constantly, always will be. There's never going to be a day where somebody says, "Well, that's it. I guess we're.
I've learned it all.
I guess we're done evolving."
And the trick of that, I think, is to understand, is to not bitch about it, right? Don't bitch about that your job's evolving, but to understand how it's evolving and then understand how yours is evolving and then have that communication to say, hey, yours is doing that, mine's doing this. How can we do this together to make this thing really cool?
Embrace it. Embrace the change.
It doesn't. It's fighting it is a waste of time, effort,
losing battle.
Yeah, it's like reading. It's like reading DMs on you post something. Like it is. Don't even read it.
Yeah, we aren't going to talk about what you're getting in your DMs.
Yeah,
so
just,
it's no good.
It's just that there's no productivity in trying to fight something that doesn't. That's evolving.
Yeah,
it's.
You know what? I think that's. I think we just solved half the world's problems
That's
right there, right?
Oh, but we drank a really good whiskey.
Great whiskey, but that's a great note, right? Like evolve, change, embrace it. Everybody's role is changing.
Sure.
Everybody's role is evolving all the time. And if we think that the whole world isn't evolving, well, I'm not sure what to tell you.
Yeah. And
right,
manufacturing of steel is going to get more automated. At one point, whenever the thought robots would show up, there's plenty of customers that have robotic welding. Then they maybe robotic assembly. Then they maybe have robotic, material handling.
Yeah,
I've seen that progression. So it is getting more automated, and data is going to drive it. And so, accept it. Hopefully, get paid for it.
Embrace it, and you know what? More than that, just maybe don't just accept it. Don't just embrace it. Like try to be on the
excel at it.
Excel at it. Do try to see, okay, what's coming? How can I separate myself? How can I make my business stand out? How can I make myself personally stand out and become better? Because I've been on both sides of the fence and I've fought the change and I've embraced the change. Typically, fighting it is not the best option in my experience. Sometimes it is, not always, but
I do
more often than not, embracing it and trying to be out in front of it gives me better results.
I do have roots in Oklahoma, and I've learned that it's way more fun to be inside the tent peeing out than outside the tent peeing in.
Yes. So, well, I feel like we went through the whole progression, right? Shop drawings, bill of material, CNC, EDI, model interchange, robotics, more machines, more integration.
Cloud I think is there. I think there's more to hit, but I think that's enough to absorb.
Kind of the high levels, right? And it gives everybody a great idea of how much it has evolved and changed, right? There's been several evolutions of this already, it feels like. So
if there was a word of advice or encouragement or whatever is, I would say everybody in the construction process should ask, like I ask myself, what are we selling? What are we doing? What is our job? What is my function as an architect? How far do I take it? What is my job as an engineer? How far do I take it? What is my job as a detailer, a manufacturer, and how far? What is my job as a director?
Yeah.
Re-ask that question because it's changed.
Yeah.
It's changed. And if you don't think it has, then you're probably not getting as many jobs, or you're spending a lot more on that job than you need to. So just keep asking yourself that question and then accept what you find.
Very good. Well, that's it for another Steel and Whiskey. Doug, appreciate you stopping by.
Thanks
Always
for having
great.
me. I let me drink in my boots.
Hey, yep, no, appreciate the words of wisdom. Always fun. Always a great time. So we'll see everybody next time.
Take care.